All right, let's dive right in. Today, we're going to pull back the curtain on the hidden reason your internet might feel slow. And here's the hint. It probably has nothing to do with your provider. We're talking about the cables, the physical wires inside your walls, and the absolutely brilliant science that makes sure they're working perfectly.
You know the feeling, right? We've all been there. You pay good money for that top-tier, blazing fast internet, but the performance just isn't. You blame your provider, you restart the router for the 10th time, maybe you even blame the weather. But what if the real culprit is hiding in plain sight, right there inside your walls? That's what we're digging into. What is so often the most overlooked part of any network? The actual physical cabling. It's kind of like the foundation of a house. It's the foundation of our entire digital world. And when it's not perfect, everything built on top of it just starts to crumble. See, a cable might look totally fine on the outside, but inside, oh man, tiny imperfections, a bad installation job, or even hidden damage can just wreak havoc on your data signals. These little issues are like a silent saboteur, causing those annoying slowdowns, dropped connections, and just endless frustration. So, how in the world do we fight back against this invisible enemy? Well, we bring in the hero of our story, Fluke cable testing. Now, this isn't just about plugging something in to see if a light turns on. No, this is a professional-grade certification for the actual highway our data travels on. Let's break that down, because it sounds a bit technical. A Fluke test is basically a deep diagnostic health check for your cables. It uses these really sophisticated tools to send signals flying down the line, and then it listens super carefully to the response. It's all about making sure every single wire meets these incredibly high standards for both performance and quality. But that kind of begs the question, right? How can a device possibly see inside a sealed cable? I mean, it's not magic, even though it feels like it. It's just brilliant science. So let's look at how these testers build a complete picture of a cable's health step by step. Okay, so the whole process is incredibly methodical. First, the tester sends a bunch of signals down the wire. Simple enough. Then it starts analyzing all these key metrics. Things like how much signal strength is lost over the length of the cable, that's called attenuation. It also measures how much of the signal gets reflected back by tiny imperfections. We call that return loss. And it even listens for electrical noise that's bleeding between the different wires, which is known as crosstalk. Finally, after all that, it detects any physical problems, breaks, wiring mistakes, you name it. And here's the really game-changing part. It tells you exactly where that problem is. You know, a really great way to picture this is to think of it like sonar, but for your cables. The tester sends out a ping, and then it just listens for the echo. By measuring the exact time it takes for that echo to come back, it can literally map the inside of the cable and pinpoint a fault down to the inch. It's amazing. Now, the official name for this sonar tech is time domain reflectometry, or TDR for short. And this is what gives technicians their superpower, the ability to find a tiny break in a 300-foot cable that's hidden behind a wall, all without tearing everything apart. It is an absolute game changer for troubleshooting. Now, all this testing isn't just some random checkup. Nope, it's a really rigorous exam where the cable is basically graded against globally recognized standards. You can think of it like a strict rule book that makes sure a cable installed in New York performs exactly the same as one installed in Tokyo. So, who writes this rule book? Well, there are three main players you should know about. In the US, you have the TIA, and they set the category ratings. If you've ever bought a Cat 6 cable, well, that's them. Then there's the ISO/IEC, which sets similar standards for pretty much the rest of the world. And finally, you've got the IEEE. They're the ones who say, okay, for a cable to handle 10 gigabit Ethernet, it has to meet these specific performance targets. They make sure it all works together. And just like there are different rules, there are definitely different tools for the job. You wouldn't use a basic little tool meant for a home project to certify a multi-million-dollar data center, right? The tools really fall into three distinct tiers. Let's break down these tools into those three tiers. At the basic level, you have verification testers. These just answer simple questions like, is it plugged in right and are the wires in the right order? And you take a step up to qualification. These testers ask a much more important question. Okay, we know it's wired correctly, but can this cable actually handle 10 gigabit speeds? But at the very top, at the pro level, you have certification. These are the heavy hitters. They don't just ask, they guarantee that an installation meets every single one of those strict industry standards we talked about. This is a must-have for the pros and is often required just to get a manufacturer's warranty.
So this brings us to the big so what question. Why go through all this trouble? Why invest in this level of super detailed, rigorous testing? Well, the answer is pretty simple. It's all about guaranteeing performance now and preventing massive headaches later.
And the payoff is huge. For any new building or installation, it proves the job was done right the first time. It's also absolutely essential for unlocking those long-term product warranties from the manufacturers. For troubleshooting, my gosh, it saves countless hours by pinpointing the exact problem instantly. And in those critical places like data centers or industrial factories where a connection failure is just not an option, certification isn't a luxury. It's an absolute necessity.
So the next time your connection feels a little off, just remember to look past the router and the modem. The real bottleneck might just be the physical path itself. In a world that is demanding more speed and more reliability every single day, it's the quality of our unseen infrastructure that truly separates a fast, seamless connection from a frustrating one.